Welcome to our exploration of Python functions and loops. These are fundamental building blocks that allow us to create reusable code and automate repetitive tasks. Today we'll learn how to write efficient, organized code that can handle complex operations with elegance and simplicity. By the end of this session, you'll understand how to create reusable blocks of code with functions and automate repetitive tasks with loops. These concepts are crucial for writing efficient and maintainable Python programs. We'll focus on practical applications and common programming patterns. Functions are reusable blocks of code that perform specific tasks. They help us organize code, avoid repetition, and make programs more maintainable. The def keyword creates a function, followed by the function name and parameters in parentheses. The docstring, triple-quoted string, provides documentation about what the function does. The return statement sends a value back to wherever the function was called. Functions can accept different types of parameters, required parameters, optional parameters with default values, and even variable numbers of parameters. Return values give functions the ability to send back results. Python functions can return multiple values as tuples, which can be unpacked into separate variables. This flexibility makes functions powerful tools for organizing code and processing data. For loops are the workhorses of Python iteration. They provide a clean, readable way to repeat operations over a sequence of items. The range function generates a sequence of numbers, perfect for counting loops. When iterating over collections like lists, for loops can directly access each item. The enumerate function is particularly useful when you need both the item and its position in the sequence. While loops continue executing as long as their condition remains true. They're especially useful when you don't know in advance how many iterations you'll need. The break statement provides a way to exit the loop based on a condition. Always ensure there's a way to exit the loop to avoid infinite loops. Remember to update the condition variable within the loop when necessary. Loop control statements give us fine-grained control over loop execution. Break exits the loop entirely, continue skips to the next iteration, and the else clause executes when a loop completes normally, without break. These tools help us handle special cases and create more sophisticated loop behavior. Combining functions and loops creates powerful programming patterns. Functions provide structure and reusability, while loops handle repetitive operations within the function. This example demonstrates processing a list of scores, the function encapsulates the logic, and the loop handles the individual calculations. This pattern is common in data processing and analysis tasks. This practical example shows how functions and loops work together in a real-world scenario. The function processes temperature data, using a loop to analyze each day's temperature while keeping track of statistics. This pattern is common in data analysis, where you need to process collections of data and return multiple results. Notice how the function encapsulates all the logic, making it reusable for different temperature datasets. Following best practices leads to more maintainable and readable code. Functions should be focused and well documented. Use meaningful names and type hints to make code more understandable. Common loop patterns like accumulators and filters are powerful tools, learn to recognize and use them effectively. Remember to handle edge cases and validate inputs to make your functions robust. We've covered the essential concepts of functions and loops in Python. These tools form the foundation of procedural programming and are essential for writing efficient, maintainable code. Remember to practice these concepts by writing your own functions and working with different types of loops. Start with simple examples and gradually tackle more complex problems. The combination of functions and loops will allow you to solve a wide range of programming challenges.